In this video, I'm going to be looking at how you can use equations and variables in SolidWorks to sort of build these really nice relationships between different features that you're using to create your parts. So this is a beginner's tutorial. It's going to be really short, and it's going to be using this very simple model I have. It's just two features, a boss extrude and a cut extrude. Already I have this equations folder that I can right click and I can select manage equations. And if you can't see that, you can type equations in the search bar, select enter, and that will bring up the same window. So I've defined these three global variables: length, height, and cutout height. I've set the length to 105 millimeters, the height is 70 millimeters, and the cutout height is 15 millimeters. And we can use these to drive the dimensions for this part. So we have this base extrude. I want to bring up some more dimensions. It's not going to do that. So we'll go and edit the sketch. This bottom length here, you know why it didn't bring up any dimensions? It's because it's not defined. So what we will do is we'll actually define this sketch based on these equations. I had a different part that I was working on and it was defined, so I think that's why, and then I sort of got rid of it, start again for this tutorial. But if we go ahead, create a new dimension, press equals, we can create an equation to one of these variables. So I think this is from me playing around with the variables as a tool. If we don't have that equation and we select the length here as, it will set it to 105. You can see the height's not yet defined. We can click on the resolve, or we can exit the sketch. We can rebuild our sketch. If we select it here, you can see that this length of the base is 105 millimeters. If we go into our equation and we select manage equation and we change this to say 85 millimeters, select OK, we rebuild our model, nothing changes. So what we want to do instead is we want to put an equal sign in front of our global variable, which creates an equation which references this variable. So if we go equals length, we select the check mark, we select save, and we don't need to be in the sketch, but we can rebuild the sketch. If we now come back to the equations and we change this value, maybe 120 this time, and select OK, you'll see that the model updates. If we come into our equations and select manage equations, we have this line here. This is D1 at sketch 3. I assume that means a dimension 1 for this third sketch here, and it's equal to our length, which is this global variable that we defined, and one that we can change very easily too. So you can use global variables just to set positions without actually having them relate to that variable. So you can just use length as a number for 120, or you can drive it with an equation. So another sort of cool thing about this is that you can build more complicated equations when you're using variables and equations. So if you want to have some relationship between this length here and possibly the height of this cutout, you can do that. So our length is 120 millimeters and our height at the moment is 40 millimeters, and you can see this little indicator here shows that the sketch isn't fully defined. Maybe I will just quickly fully define it, just because it is good practice. But we're not too worried about the height just for this quick tutorial. I'm going to change the perspective back to I think it's isometric. Yeah, it is. This isometric view. So this cutout height is 40 and this base is 120. But and so that means there's a sort of 1 to 3 ratio going on, but I've set this height as a fixed 40. So what I can do is I can double click on it, press backspace, select global variables, and select our cutout height. And that's going to change it to 15 because that's what it is set to under the equations and variables folder. And you know what? I haven't tried this, but we'll give it a go. Instead of our cutout height being 15, we are going to try and make it the length divided by 3. Which, when it computes, it brings it back to 40, which is really cool. And you don't have to do that within the variable itself. If you had multiple cutout heights and you had just 15 millimeters and you want duplicates, or maybe, actually I've got an idea, maybe you want this cutout to be twice as much, the length of the cutout to be twice as much as the height of the cutout. You can double click on this. You can create an equation just by pressing equals, select on the dimension, and I'm using the asterisk for multiply by 2. I'm going to hit select or save and rebuild, and this dimension is now driven based on this dimension, which is based on this length dimension here. So we're using a mix of equations and variables, and I encourage you to play around with these yourself to try and understand the limitations and the possibilities as well with this sort of technique, which is it can, if you've got like a set of specifications that you have to meet and one of them changes, if you've defined things using equations and variables in SolidWorks, it can actually have this really nice flow-on effect where you're not having to worry about dimensions later on if they're all relative to a few core dimensions. It doesn't always work, but it can be a really powerful tool. So if we change this, instead of 120, maybe a company that we're designing this part for said, actually, we don't want it to be 120, we want it to be 240. We can just type in 240, press OK, and we can rebuild it. And because we didn't, the reason it looks like this is because we don't have the height of this base extrude driven by a variable. So when I dimension that in this video, I set it to 70. If I set it to 100, you can see that that relationship can change, but we never actually created a variable or an equation to drive it. So those are it's actually a good example of sort of the flow-on problems that you can sometimes have if you're not using relationships, and variables and equations can be really good relationships you can use when you're designing parts in SolidWorks. So if you've learned something from this video, please subscribe, like the video, and if you like this sort of short form of content, these really sort of more basic and simple videos that are quite short, just let me know in the comments. That would be really appreciated, and I'll come up with something new in the next time. I mean, this was a bit different because I've only really done sort of electrical and programming based videos in the past, so I thought I'll throw a SolidWorks tutorial and maybe we'll do a more sort of intermediate or advanced one in the future if I've got some more time to plan one out. But something like this was really easy for me to throw together, so hopefully it's been of some value. You've learned something new, and I encourage you to go ahead and play around with the equations in SolidWorks and the variables as well, and sort of see what sort of limitations again and what sort of possibilities they can offer to your project. And we'll see you next time.